Okay, let's start. Thanks for the organizer's invitation. It's my great honor to be here sharing some of the works which have been done in our team. This is Yingui Xu, the head of the Vision Lab from Alibaba Damo Academy. First of all, I would like to give you a brief introduction to our Vision Lab at Alibaba Damo Academy and the works that we are interested in. Here, 4 applications areas are listed: e-commerce, 3D vision, intelligent earth, and digital editing. To support the algorithm deployment and the product development efficiently, we have developed our own training acceleration engine, inference engine for model serving, and large-scale unstructured source media analysis engine. To summarize, our team has carried out in-depth research in several directions, including: first one is a low-level vision layer. Usually, low-level vision model is introduced for pre-processing and post-processing operations for a vision-native product. Pre-processing operators are often introduced to eliminate imaging quality problems of vision sensors for downstream vision tasks. In the meanwhile, post-processing operators are introduced for enhancing user experience. The second is perception layer, perceiving the world around us, that is, understanding and modeling and acting on visual, auditory, and multimodal input. Continues to be a research area with the potential to be beneficial in our everyday lives. With the trend of the content evolution, the classical perception tasks such as classification, detection, segmentation, key point detection, and depth estimation, pose estimation, and so on, are always be the subjects of our long-term research. The third is cognition layer. Often what we really bring business value requires us to go further on the basis of perception and realize cognition. Therefore, cognition tasks like tracking, search, clustering, event detection of visual entity, atomic detection, and the relation among objects are researched in our team. The fourth one is generation layer. If we see the visual perception and the cognition realize the deconstruction of unstructured data, we can see that generation is used to realize reconstruction on the basis of deconstruction, thereby maximizing the value of atomic content. And the last one is the 3D reconstruction and the interaction are the research topics for facing up the future, because the real world is 3-dimensional. Only by realizing the scalable 3D reconstruction for people, objects, and the environment, a truly meaningful digital world can be realized, providing more immersive content experience and interactive experience for the end users. Hereafter, considering the theme of the workshop and the time of the report, only 3 representation efforts in the e-commerce area in our lab are briefly introduced here. Hopefully, you will be interested in this work. Nowadays, live stream and short video have become one of the most popular ways for product promotion and on e-commerce platforms such as Taobao. Here we give the definition of shoppable video, which is a kind of system with the characteristic of multimodality and multi-interaction. It enables the consumers to open and browse accurate products without navigating away from the video or being redirected through multiple pages and links. The challenges behind the shoppable video systems are: the first one is domain gap. Since we need to build the link between the object in the short video, live broadcast, or image domain, we have to design a model to bridge the gaps of the semantic representation due to the differences of shooting method and backgrounds. The second challenge is large scale. For the daily job, the system should be capable of building the navigatable links from millions of 20 seconds short videos tens of thousands of 3 hours live broadcasts, and the billions of product images. So the video commodity localization is a core component of shoppable video system. In the traditional way, giving untrimmed videos, existing approach requires the sellers manually attach images of selling products to the timestamp of product exhibition in video. To solve the problem, we present an innovative demonstration of multimodal retrieval system called Fashion Focus, which enables exactly localizing the product images in the online video as the focuses different modality contributes to the commodity localization. Visual content, interaction, context, linguistic features are jointly investigated via presented multimodal learning. Our system employs two approaches for analysis, including video content structuring and multimodal retrieval, to automatically achieve accurate video-to-shop matching. Fashion Focus presents a unified framework that allows the user to search relevant product exhibitions during the video and helps the sellers to effectively deliver the products as the focus over search and recommendation. To explain the work, first of all, I would like to mention that during the live streaming, the sellers often display, exhibit, and introduce hundreds of products. If the customers intend to buy the items that the seller is explaining, they have to select them manually from the list associated with the live stream, which greatly affects the transaction efficiency. It would be more valuable to automatically identify the currently explained items according to the visual and explaining content, and recommend the corresponding purchase link of the products to the user. The user's shopping experience will be greatly improved during the live streaming watch. In our system, images of products list and the live streaming video are given as input. The matched products with the timestamp are localized as output. This figure shows the workflow of our system. There are two stages in our system. The first one is video content structuring, aims to locate the instances in the untrimmed online videos with both categories and consistent object tracks. And then, multimodal retrieval process presents a compact retrieval solution with multimodal information using visual and language representation, which improves retrieval quality by triplet-to-image metric learning with triplet constraint. The streaming engine, including the above two procedures, is developed to provide real-time services for tremendous videos in Taobao marketplace. This slide is to introduce another valuable product, online item intelligent publishing system, which is deployed in the Yingui mobile app, which is the largest second-hand marketplace. It is designed for personal sellers to publish their items in an automatic way with the uploaded images. The proposed system not only can get sellers to capture more detailed information by category recognition, but also can tell the seller exactly what this product is and which attributes it has. The system has been deployed in the Yingui mobile app. The following visual tasks are involved in the system. The first one is category and SPU recognition task, in which the extreme classification model we developed is adopted. The second is attribute recognition task. So one stage label set embedding is employed to learn an image and its associated label set to the multimodal embedding space to capture the dependency between different attributes. So let's introduce the process briefly. So when the images are uploaded to the online platform, our system firstly predicts the category of the item, and then we provide the corresponding picture template based on our predicted category, so that we can get the user to capture more item details by following the templates. Both the initial image and the extra captured detailed images will be fed into our deep network for further understanding of the item. So the users want to sell their product faster. Therefore, they have to list as much item information as possible, such as product's name and brand. Thus, we employ two simple yet effective classification modules for SPU and attribute recognition. The SPU can be considered as the smallest unit of aggregated product information. Our system can accurately identify SPU so that we can know most information for the published item. Besides, our attribute recognition will recommend the most relevant attributes of the item, like the brand, style, material, and price. All the information recognized by our SPU and attribute module will be dumped into the retrieval engine to encourage as much exposure as possible. So here we give the 3 interesting application demos. I hope to give you more intuitive feeling of multimodal technology products. Please take a look at.
是施展的一个感觉，施展的一个状态。所以的话呢，就是看起来的话呢，就比较的比较。
This is for the product search, and the system automatically recognizes the product in the video, and then user can click the product and perform the search process. This is the item publishing system. So the user the sellers just simply upload the image, and we provide the template to allow the sellers to provide more information. And the back end is our product attribute recognition system. So we also do the price estimation. Okay, then the item is published successfully.
是施展的一个。
Okay, so next let's introduce to you the technical exploration we have done in the direction of virtual AI assistant. There are different AI assistant robots that has been deployed in the e-commerce platform. For example, the chatbot used in help task, which usually takes the forms of text or voice services. Here, we hope the development of AI-driven virtual avatars can bring the following business values. First, with the help of AI-driven virtual avatars, extending the life cycle of a live broadcast, breaking through the broadcaster's working hour limits. The second, with the help of AI-driven virtual avatars, providing merchants a virtual image to show their own marketing skills without appearing in person. To realize virtual human technology with realistic user experience, the following 3 key technologies are developed. The first one is speech to animation, which is to realize the facial and body movements generation based on the input text. The second is photo to avatar, which is to realize customized avatar appearance generation based on the input photos. The third one is video to animation, which is to realize facial and body motion capture via RGB camera in real time. First, I would like to introduce the speech to animation technology we have developed in our system. So it is defined as utilizing text and speech as input signal, and driving avatars to act like a real person, including the facial impression, lip synchronization, the hand gesture, and body movement. The process may face many challenges. The first is the gap between the low-dimensional input data and the high-dimensional output. The second is that we need to handle the trade-off between the diversity and the aesthetics. As shown in this figure, our approach consists of two components, each of which generates the facial and body animations respectively. As for the facial animation, we propose using cross-model attention network to explore cross-model context correlation between the facial landmark and audio, as well as phoneme and audio. For accurate lip movement generation. Second, we propose a motion style transfer mechanism, which utilizes adaptive instance normalization to transfer the emotion style of any input source to the target face animation. For the body animation, we propose a deep learning network architecture to generate the body movements. Additionally, text analysis is used to extract semantic text for generating facial expressions. So in this video, we show that for a given text input, our algorithm can generate natural and diverse facial and body movements.
并且方头鞋型显复古风，自带端庄大气质感，而且低筒的设计可以修饰脚踝，而且不会显得臃肿，看起来活力满满。喜欢的人千万不要错过了哦！还有啊，头层牛皮的材质制成，富有光泽感，质感十足，透气性，上脚后不易感到闷热。主播也很喜欢这款商品，采用金属拉链头设计，简约经典，低调有型，穿着舒适。宝宝。
Okay, so let's move the photo to avatar part. So this slide gives a brief illustration of photo to avatar work. It helps customize the avatar's appearance with limited human input and effort. The model we proposed here have two features. First one is weakly supervised. The training data mainly consists of the images rather than 3D annotated data or scanning results. The second one is customizable and extendable. The reconstructed faces are weighted sum of the meshes and the texture bases, which make our technology easy to switch between different styles through different set of bases. The red figures show the results of our method. We can see that the results improvement with lighting and shading. So the last slide is for the video animation part. This slide presents our video to animation research. We introduce a statistical articulated 3D human shape modeling pipeline within a fully trainable modular deep learning framework. Such model enables 3D human pose and shape reconstruction from low-cost multi-sensory devices. The techniques are used in Taobao Shop live streaming for selling products. Therefore, the algorithm should be real-time and low-cost with high precision. Our method can accurately reproduce the facial, body, and hand movements from input videos. Our method treats face, body, and hand separately. For body and hand, we estimate not only the key joints, but also the meshes. Meanwhile, the method is lightweight enough to run on PC for real-time applications. Here we have two videos that demonstrate our results. The first is a video to animation for bodies. This is for bodies. So we also compared our results with the MediaPipe, which is researched by Google.
动态动作效果展示。 森自由欢喜痛苦受苦。
The second one is results for physics.
上次请明星这个单频率度非常大，然后这次 ，Oh my god， 我怎么卖呀？哦累加码福利来喽！哇哦，哇哦，哇哦！哦累，我觉得 ，Oh my gosh， 买它，买它，买它，买它！相当于一只小白伞只要109块钱。Oh my gosh！
Okay, that's all my talk. Thanks for listening.